So we're going to talk you through example 4 of section 7.1 on finding the determinant. And here is our first example where we find a determinant of a 3 by 3 matrix. And you'll notice in the explanation, we are writing it as 3 times the determinant of a smaller matrix minus -2 times the determinant of a smaller matrix plus 1 times the determinant of the smaller matrix. The 3, the -2, and the +1 come from the top 3 entries of the matrix, the first row. But it turns out, we will see later, you can use any row or column to compute a determinant, and it's done recursively. So in other words, you're going to need to know how to do 2 by 2 determinants in order to do a 3 by 3. So I'm going to go ahead and use the second row here. And the thing to do is to remember this little checkerboard pattern that you see here on the right. You simply put a plus sign up on the top left and a minus sign, then a plus sign, and they alternate like a checker or chessboard. And that's why when we did the explanation of example 4, the numbers 3, -2, and 1, notice that the -2 is subtracted. There's a minus sign in front of it because that corresponds to this entry here. So when I go across the second row to compute the determinant, well, I'm going to have a -5, I'm going to have plus a -1, and I'm going to have a -2 also. So let me go ahead and change pens. So when I do the -1, I will have plus -1 times the determinant of a 2 by 2 matrix. So how do you know what the 2 by 2 matrix is? Well, basically when you're at the -1, you can cross out the entries in the same row and column as that -1. And the leftover numbers are 3, 1, 1, and 1. And so that is the 2 by 2 matrix that goes here. Let's see how that works with the -5. I'll switch back to the red pen. So when I have my 5, again, it's negative because of the checkerboard pattern, times, now I need to put a 2 by 2 matrix here, and I'll take the determinant of that 2 by 2 matrix. So when I look at the 5, I notice that it should be negative. I have -5. And the 2 by 2 matrix, if I cross out the row that the 5 is in and the column that the 5 is in, and I look at the other entries, I see I have left a -2, a +1, a +4, and a +1. So now what about when I get to the last entry here? That 2 is negative because of the circled negative sign, right? So if I cross out this row and this column, do you see the entries that we need? Well, we need 3, and we need -2, and we need 1, and we need +4. So I'm going to go ahead and switch to my blue pen and try to finish the calculation. So let's see. The determinant of A equals -5 times, now the determinant of this 2 by 2 matrix, I do -2 times 1 is -2 minus 4, because 4 times 1 is 4. Now I'm going to write -1 times, do you see the determinant of the black matrix? 3 times 1 is 3, and we minus the product of the other diagonal, so 3 minus 1 is 2. And then we subtract 2 times, and again, what's the determinant of this red matrix? 4 times 3 is 12. And then I subtract 1 times -2 is -2, right? So let's see what this equals. This is -5 times -6 minus 1 times, well, 3 minus 1 is 2, minus 2 times, well, here I have 12 minus -2. That's 12 plus 2. That's 14. All right, so let's work out what this is. -5 times -6, that's 30. But then I have to subtract 2, and I have to subtract 28. 30 minus 2 minus 28 is 0, which is exactly the same as what we got when we went across the first row. And as I said before, you can also use columns. So we're going to do that next. So let's compute the determinant again using the first column. So I'll expand down the first column, and I notice that the plus minus plus in the checkerboard goes like this. So it's going to equal, the determinant of A is going to equal 3 times the determinant of a small matrix minus, because of the checkerboard pattern, 5 times the determinant of a smaller matrix plus, well, 1 times the determinant of a smaller matrix. Can you see what these matrices should be? 3 times the determinant of -1, 2, 4, 1. That's the smaller submatrix. That does not include the entries in the same row or column as 3. Minus 5 times what submatrix? Well, it would be -2, +1, +4, +1. Plus 1 times the determinant of what submatrix? Well, it would be -2, 1, -1, 2. Because again, if you don't want the things in the row or column with 1, then you're talking those numbers there. So we can work this out, and you can work out the rest and check that you're going to get an answer of 0.